All right, let's go on a bit of a journey, shall we? We're heading out into our cosmic backyard, the solar system. And yeah, we all think we know it, but today we're going to push past the familiar planets and find out just how huge our little corner of the universe really, truly is. So let's dive in. Look, we all learned about the planets in school, right? Mercury, Venus, Earth, Mars, and so on. But the solar system is so much more than that. The real question, the one that kind of defines our place in the cosmos, is where does it all stop? Where does the sun's pull finally give way to the emptiness of interstellar space? That's the mystery we're unraveling. So before we venture out to the absolute edge, let's start with a quick tour of the neighborhood we all recognize. Just to get our bearings and break down the classic components. At its heart, our system is really just one star, our sun, and everything that's gravitationally stuck to it. And that includes the 8 planets, of course, but also, get this, over 400 known moons, plus a truly staggering number of asteroids and comets. It's a busy, dynamic place, and it's all held together by the sun's incredible gravity. But how did this whole neighborhood even come to be? Where did it come from? To really get a feel for its structure, we need to rewind the clock way back. About 4.5 billion years, actually, to witness its fiery birth. So the whole thing started with this giant, cold cloud of interstellar gas and dust. And something, we think maybe the shockwave from a nearby exploding star, a supernova, caused it to start collapsing in on itself. Within just a few thousand years, the center got so hot and so dense that our sun literally burst into life. All the leftover stuff flattened out into this spinning disk. And that's where, over millions of years, the planets we know today were violently smashed together. You can almost think of it like a 4-step cosmic recipe. First, you have the collapse. Then, ignition. Boom, the sun is born. After that, flattening, as everything else forms that spinning disk. And finally, accretion. That's the cool part where tiny dust grains start sticking together, forming bigger and bigger clumps, until they grow into full-blown planets through just countless collisions. It's an absolutely incredible story of cosmic construction. And what's just staggering is the sheer dominance of the sun in all this. After that initial collapse, it basically gobbled up almost everything. 99.85% of all the mass in our entire solar system is locked up inside our star. The planets, the moons, you, me, all of us, we're just the leftover cosmic dust. Literally. And this whole creation process, it perfectly explains why our solar system is split into 2 totally different zones. Close to the young, super hot sun, only heavy, rocky stuff could survive the heat. And that's why we have the small, dense inner planets. But way farther out, in the freezing depths of space, lighter materials like ice and gas could clump together, forming those massive gas and ice giants. It's not random at all. It's all a consequence of temperature. Okay, now that we've established our home base, it's time to take that journey. We're heading outward, past the orbit of the very last planet, Neptune, and into the true deep space of our solar system. Our first stop is the Kuiper Belt. The easiest way to think about it is like a second, much larger asteroid belt. It's this vast, donut-shaped region just filled with icy bodies, basically leftovers from when the solar system formed. And yep, this is the famous home of Pluto. But this is not the edge, not even close. If we push even further out, way beyond the Kuiper Belt, we run into something truly immense, the Oort cloud. Now, this is theoretical, but it's a very widely accepted idea. It's not a belt or a disk. It's a massive spherical shell of icy debris that completely surrounds our entire solar system, kind of like a giant cosmic bubble. And just how big is this bubble? While the Oort cloud is thought to stretch out maybe 1.5 light-years away from the sun, that is nearly a third of the way to the next star system, Alpha Centauri. That's an almost incomprehensible distance. And right there, that's our answer. The Oort cloud, that's the true gravitational boundary of our solar system. The edge isn't an orbit. It isn't a planet. It's the farthest point where a lonely piece of ice can still feel the faint but persistent gravitational pull of our sun. To try and put that scale into perspective, just think about our fastest, most distant explorers, the Voyager probes. They've been traveling since 1977 and have only just recently crossed into interstellar space. And yet, it will still take them thousands of years just to pass completely through the Oort cloud. That is the unbelievable scale of our solar neighborhood. So now that we've finally found the edge of our system, let's take the ultimate step back. Let's see where our tiny little bubble sits within our home galaxy, the Milky Way. So here's our cosmic address, a pretty quiet spot out in the Orion spiral arm of the Milky Way. But we are not sitting still. Our entire solar system is hurtling through space at a mind-boggling 828,000 kilometers per hour. And even at that blistering speed, it takes us 225 million years to make just one single trip around the galaxy. That's one galactic year. And our sun? It's just one star among a staggering crowd. Our home galaxy, the Milky Way, is home to an estimated 400 billion other stars. 400 billion potential suns. And you have to think, many of them probably have their own families of planets. But let's just zoom out one final time. Our galaxy, with its 400 billion stars, is just a single grain of sand on an infinite cosmic beach. The latest estimates suggest there are probably 2 trillion galaxies in the observable universe. 2 trillion! It's a number so vast our minds can't actually comprehend it. Okay, after that mind-bending journey across cosmic scales, let's bring it all back. Back through the trillions of galaxies, past the billions of stars, through the vast Oort cloud, and all the way back home. And here is the most profound fact of all. For all of that vastness, for all those stars and all those potential worlds, our solar system is the only place we have ever found that can support life. And within it, Earth is the only place we know for sure where life actually exists. In all that cosmic emptiness and unimaginable scale, this tiny, fragile world is, as far as we can tell, completely and utterly unique. Our story, the story of evolution, of civilization, of consciousness, it just might be the only one of its kind. And that leaves us with the ultimate question, doesn't it? Looking back out at that incomprehensible number, 2 trillion galaxies, it's just so hard not to wonder, is our story really unique? Or is it a story that has played out, is playing out right now, or will play out somewhere else in that grand cosmic theater?